My name is Mr. Otto, and today I want to show you how it's simple and it's the simplest to come up with the three equations the three equations of the motion. How it is simple to come up with three equations of the motion. The first equation of the motion is v, which is final velocity, is equivalent to u plus at. That is the first equation, and we want to know how this is brought about. This brought about with the manipulating of the equation of acceleration. So we know A represents acceleration. And what is acceleration? Acceleration is the change of velocity, which is the subtraction, change in final and initial velocity, the ratio of change in velocity to the time. When we multiply this, we get that A t is equals to v minus u. Let us make v the subject of the equation. V is equals to u plus at. This is how we come up with the first equation of motion. First equation of motion. The second equation of motion. The second equation of motion is brought about by the velocity time graph. And this is the shape of the velocity time graph. On the axis, the y-axis, we have the velocity, and on the x-axis we have the time. Let's make the final time to be t. Here is the initial velocity, and here is the max, the final velocity, which is presented by v. So, after having this velocity time graph, can assist us to get the displacement, which is represented by s. The displacement in the velocity time graph is the area under the graph. And what is the area under this graph? The area under this graph is represented by two figures. This one here, which is a rectangle, and this one here, which is a triangle. So to get the displacement using velocity time graph, we get the area of these two figures, which is rectangle and triangle. Rectangle, the area of finding the formula of finding the area of triangle is length times width, as we all know. And the area of finding the triangle is a half base height. What's length? The length is from here to here, which is t. And the width is from here to here, which is ut, plus I have base is u from u to t, which is t, and the height is the difference of v and u, final velocity minus u. When we manipulate this, we have ut plus I have t. What is v minus u? Let us go back to the first equation. As we were manipulating the acceleration formula of the change in velocity to t, we got that at is equals to v minus u. So here v minus u will give us at. V minus u will give us 80, which will come to be ut plus I have 80 squared, and that is how we come up with the second equation of the motion, that S is equals to ut plus I have 80 squared. Let us move on to the third equation. By finding the third equation, have to take the first equation, which is velocity is equals to final velocity is equals to usual velocity plus at acceleration time. So after getting this, we will have to square both sides. V squared is equals to u plus at squared. You will get v squared is equals to u squared plus 2u at plus s squared t squared, which will come up as v squared is equals to u squared plus 2a. If you come here, this part is just fine, but this part here, we have a here, we have a here, we have t here, we have t here, so we have to simplify this equation here for us to get the third equation, which will give us 2a will give us ut plus this 2a, we have here a squared, so it will give us a half a t squared. V squared is equals to u squared plus 2a. What is ut plus a half a t squared? Let us go back to the second equation. Second equation says f is equals to ut plus a half a t squared. So equivalent to this one here, ut plus a half a t squared will give us s, and therefore we'll have v squared is equal to u squared plus 2s, and this will give us the third equation of motion. Thanks for watching the video, and I would like you to subscribe and click the bell ring on your screen so that you may be getting my update